This video will cover SAS, SSS, ASA, and AAS proofs in triangle congruence. SAS, SSS, and ASA, and AAS, oh my goodness, all four of them, are just talking about proving triangles congruent using 4 different theorems. Now we know that there's 5 theorems, but we'll get to HL in a later topic. All of these have S's and A's, and it's important to remember that S stands for side, and A stands for angle. It's important to understand that when we're doing these proofs, we need to mark up our givens. Everything that they give us in the first statement here, the given, needs to be marked up on our picture. If we don't mark it up, then we're not going to be able to prove what they're asking us to prove. So first I'm going to state everything that they told me. AB is congruent to ED. BC is congruent to DC. And C is the midpoint of AE. I know it's a long given, but you do have to write it all. If you don't write it all, you lose credit. So now I'm going to go through and mark up the pieces of information that they gave me. AB is congruent to ED. BC, notice 2 hash marks now, is congruent to DC. And C is the midpoint of AE. Now we talked about that word midpoint in our previous video on topic 3, where we talked about important proof steps. If we have a midpoint, that tells me something very specific about 2 segments. Remember that a midpoint divides a segment, AE, into 2 congruent segments, AC and EC. So now that I've marked that additional piece of information on my picture, I need to state it in my proof. AC is congruent to EC. And our reason again comes from the fact that we had a midpoint. So I'm writing that definition. Midpoint divides a segment into 2 congruent segments. Now that I have a midpoint that gave me 2 congruent segments, I get to mark up my picture with S's and A's. So I have 1 set of sides, 2 set of sides, and 3 set of sides. So now I can prove the triangle is congruent by the theorem SAS, because I had 3 sets of congruent corresponding sides. That's it for your first proof, 3 steps. Now, they're not all 3 steps. Some might be a little bit longer. Sometimes you can prove it in 2 steps, depending on what's given to you in the given. Now, I'm going to pause on this example 2 for a second. If you want to pause the video and try it on your own, this would be a great opportunity to do so. And then when you're ready to check your answer, or if you get stuck, just hit play and you'll see me walking through the video. So here I'm going to start with my given, AE and BD bisect each other at C. Now that word bisect means to cut or divide into 2. So here AE bisects BD. So that means BD is getting cut in half. But because it says that they bisect each other, that means also that AE is getting cut in half. So I'm going to make statement 2 with 2 sets of congruent parts, meaning BC is congruent to DC, and we also found out that AC is congruent to EC. Our reason for that comes from the fact that we had a segment bisector. So again, this is where we write the definition. As you can see, it's important that we start memorizing definitions, otherwise we're not going to be successful in proofs. So here I've got segment bisector, divides a segment, into two congruent segments. At the midpoint. If I try to mark up my picture right now the way that it is, I see one set of sides and two sets of sides. Notice that SS is not enough to prove triangles congruent. Remember that we need a minimum of 3 congruent corresponding parts in order to get congruent triangles. So I'm staring at my picture and I'm trying to see if there's anything else that I can mark up. Remember also that you're always allowed to mark a congruent set of sides that's shared, meaning reflexive property, or a set of shared angles. You can also mark up something called vertical angles. Those are always formed out of an X and they're opposite one another. They kind of make an hourglass shape or a bow tie. Okay, so here I notice that I've got a bow tie going on. I have this part of angle C and this part of angle C. So now when I talk about those angles, I'm going to name them using 3 letters. Angle BCA is congruent to angle DCE. And again, that was because they're vertical angles. Now I can't just stop at vertical angles. I have to actually define them. Vertical angles are congruent. That's where I get to stop. If I leave off the are congruent part, I would be losing credit. Number 4. Now if I mark this set of angles up with an A, I now have 3 parts congruent. So I think I'm able to prove my triangles at this point. Triangle ABC is congruent to triangle EDC. I have 2 sets of sides and 1 angle, and it looks like my angle is touching both of the sides. So it looks like the order of this will be SAS. Example 3 here says that we were given a lot of stuff. FA is congruent to FB, AD is congruent to BE, FG bisects an angle, and angle D is congruent to angle E. Take a second to write your first statement and your first reason. Also mark up your diagram. I'm going to pause the video and ask that you pause it also while I do the same that I've just asked you to do. First statement, first reason, mark up your picture. Okay, so you should have the markings just like I do. The one thing I have not yet marked up is that FG bisects angle DFE. DFE is this whole angle up here at the top, and if I'm bisecting an angle, then that means I have 2 congruent angles. So I'm going to go ahead and state that angle 1 is congruent to angle 2. Remember, if you want to try this proof on your own, continue with the video paused. So pause the video, then check back in with me so that you can see the answers. So here, angle 1 is congruent to angle 2, and that was because of the fact that we had an angle bisector. It's not enough to just say angle bisect, we actually have to define it. So here we would say angle bisector divides an angle into 2 congruent angles. For step 3, I'm going to look at this picture again, and I notice that I marked up FA is congruent to FB, and AD is congruent to BE. But nowhere do I have a statement that says FD is congruent to FE. And that's a whole side of a triangle. It was just split up into 2 parts. So I do need to make a statement about FD being congruent to FE. Because in order to prove the triangle's congruent, I need a whole side, not just parts of sides, but a whole side congruent to another whole side. So here, if I take one part FA and add it to another part AD to get a whole segment FD, that's called the addition property. And again, addition is just where we take part plus part and we get out a whole. A partial segment plus a partial segment gives us a whole segment. Now when I look at my picture, I have one set of angles down here, angle D, one set of sides, and then I notice a second set of angles. So I'm ready to prove my triangle's congruent. FDG is congruent to triangle FEG. And when I look at this, my side is touching two angles, so ASA. Now if you're staring at this and wondering why I didn't talk about the reflexive side, FG, it's because I didn't necessarily need to. But if you want to stick it in your proof, an alternate version, an alternate ending for this would be to say step 4, FG congruent to FG, reflexive. Again, that's where we have a shared side. If I were to separate those two triangles, FG would be in both of them. So this is that reflexive property. So now based on this, my triangles are still congruent. FDG is congruent to triangle FEG. But this time I have options. It's not strictly ASA. Yes, certainly it could be ASA based on the markings that I have. But when I go back to look at the markings, I now have this angle still, a side, an angle, and another set of sides. So now I have multiple options. I could either say it's SAS, or I could say that it's AAS. Or again, I could go back to the original way, ASA. Either of these would work for you, or any of these three would work for you, as long as you're marking up the appropriate things on your picture and stating everything that you've marked up. If you mark stuff up but you don't state it, you're going to be losing credit because you don't have sufficient or enough information to prove the triangle's congruent based on the proof. For example 4, I'm going to let you pause the video if you want to try it on your own, copy it down, sketch the picture if you need to. Otherwise, I'm going to keep walking through the steps. Pause the video though for sure in order to write down first statement, first reason, and marking up your picture. Okay, so here I've marked up my picture. BC is congruent to AD, that's where the hash mark comes in. And then BC is parallel to DA, that's where that little funky arrow comes in. I'm trying to prove that this left triangle BAD is congruent to the right triangle DCB. Now if I stare at this picture long and hard, I notice that BD is congruent to itself. If I were to separate those two triangles, BD is in both of them. That's why it's congruent to itself. The reason for that, again, is because of the reflexive property. If I go to mark up my picture with S's and A's, right now I have one set of sides and two sets of sides. SS, again, is not enough to prove triangles congruent. So I have to think back to my given and make sure that I've used every part of it. There's nothing more that I could do with congruent sides. They're already congruent, I can't do anything more with it. But with parallel sides, I think that I can get a set of angles from them. If I look at my parallel lines, and I focus on one transversal. There's 3 different ones here, but let's focus on BD. I just formed the letter Z, and if you look back at some of the previous videos, I think it's Unit 2, Topic 3, with parallel lines, if you can find the letter Z or a backward Z, you have found alternate interior angles, which are congruent when lines are parallel. So here I have found a backward Z, so I can mark those congruent angles. Now I can name these angles using 3 letters like we've done in previous proofs, like CBD. Angle CBD is this one here, and angle ADB is this one here. But I can also name them using numbers, like 1 and 2. If I choose to use numbers, I have to make sure that I mark it on my picture. Can use numbers for angles. If, again, I'm going to use it in my proof, I have to mark it on the picture. So now for statement 3, I'm going to say angle 1 is congruent to angle 2. And the reason for that comes from the fact that we had parallel lines. So if lines are parallel, then the angles formed we had were alternate interior. So then alternate interior angles are congruent. Once I have that, that gives me a third piece of information, a set of angles. So now again I have S, then it's touching an angle, and that angle is touching a side. So it looks like the triangles are congruent by SAS. Again, I had a side which was touching an angle, and that angle was touching another side, SAS. If you need to rewind, go back, pause, rewind, do what you need to do, otherwise move on to your practice.